So welcome everyone to the Airships to the Arctic 2023 Airship Gateways and Corridors, Airship Corridors and Gateways to the Arctic. This is a great pleasure to be here and speak with you all. We've been working on airships at the University of Manitoba for well over 20 years. And certainly the one thing that we know for sure is that the problems that we identified 20 years ago are still with us. And in some cases, they're actually worse. As we look to today's sessions, we're going to be talking about transport to the north. That's one of our major themes of the day. But we're also going to be talking about the environment, because one of the problems we face in the north especially is climate change. It's happening much more rapidly there than it is in other parts of the world because of the high latitudes. And as a result, transportation itself is affected. We already had limited transportation, and now it's becoming more limited. So the airships are a necessary means to access the north. It's also necessary for us to cut down on carbon emissions. And one of the ways to do this is to move to a technology that doesn't have carbon-based fuels, and the airships have the potential to do this. You're going to hear about the use of hydrogen and about electric airships and solar power as well in this session. So hang on, and we'll be talking about that very soon. I'd like to also bring to your attention that there is an in-person conference coming up in September. I love webinars. They're great because we can reach so many people, and it's convenient for many people to be able to attend and hear more about this topic. But there's also something to be said for in-person meetings and a chance to actually meet the folks who are making it happen, and to perhaps for those who are interested in furthering the business side of airships, a chance to meet the players there and to discuss your ideas and your possibilities. So coming up in September 28th and 29th at Nuremberg in Germany, there's going to be an in-person airship conference, and it will focus on electric airships particularly. So for those who are interested in the issues of climate change and sustainability, this is a conference you won't want to miss. And I would like to point out that it's being organized by Dr. Pflaum, who is going to be speaking later on at the conference here this morning, or our morning at least. So let me move to the first presentation, which is actually me. And KELSEY Taylor is going to be chairing the session. So what we'd like to do today, because of the numbers and the difficulty with having questions answered or asked directly, is please put your questions into the chat. And if you could direct your questions to KELSEY Taylor, then KELSEY will be organizing the questions and presenting them, and she will be chairing the session after this as well. So look for KELSEY on the list. So I'm going to begin my presentation, which is about cargo airship technology, but specifically cargo airship strategy for Northern Canada. And this is a project that was initiated by the Canadian Arctic Innovations Association and was funded by Transport Canada through the National Corridors Fund, and participation also, of course, by the private sector, because this is a matching funds program. The steering committee, Madeleine Redfern, David Willis, and Christine Burrow, deserve special credit for getting this organized and moving it through. I'd like to point out that the group behind this is very large. Some of these are funders directly into the project. Some are giving letters of support. Others are providing their information. What I'd like to point out is that, most of these entities that you see on this list are all from Northern Canada. And it's important to point out that the people who are living there, they're living with the problem. They see the problem. This project was initiated by people in the north for the north. They realize they have a transportation problem that's very serious, and that airships could be a solution, and they would like to see that looked at in a much greater detail. So this funding that came along was to really look at developing a strategy for airships in the north, and it is the very first of its kind. So lots of credit goes to the people who were involved in organizing this and supporting it. So in terms of looking at this report and giving you a response to it, there were three primary questions that were asked. The first one is, how would these airship corridors be organized? How would you provide timely transportation services to all the remote communities and to the mining operations that are there in northern Canada? How exactly would we do this? The second question is about market demand. And this is something that a lot of people who have been interested in investing in airships have quickly come to the question, well, if we build airships, is anybody going to buy them? How big is this demand? And does it exist in the north? And can it be served in a profitable way? Very important question. And the third one is, are the costs of the airship services attractive to be embraced by the shippers of the north? Or would they have to be subsidized? In other words, can an airship service compete on its own merits? And is it attractive for the people who are going to be using it? So we'll address these questions. The first one has to do with the gateways and corridors. Corridors are essentially routes where traffic will move from supply centers. So if we look at the one over here, the yellow area, which is in the Northwest Territories, this area is basically served through British Columbia and Alberta, through Calgary, Edmonton, up through to Hay River Enterprise, Yellowknife, and then off in various means through winter roads or through small airplanes or however products are received. A barge is also moving up the Mackenzie River. So this area in yellow, from an airship perspective, this is the least cost or shortest distance area to the terminal area point here, which is the gateway at Yellowknife, and another gateway here we have at Enterprise. Moving over to Manitoba, Churchill is the primary gateway serving the north through southern part of Nunavut and northern part of Manitoba. And Thompson could also serve as a secondary gateway for southern Manitoba. Again, looking at least distance that airships would travel. So again, across the country, we have a total of about 9. The one which is not land-based, because each one of these has a land-based route, either rail or road, which there is a jump-off point by the airships. The one exception is Iqaluit, which would be sea-based, at least during the summer, and then goods would be collected here for furtherance onto the communities further north by airship. So this is what the corridors and gateways would look like from our perspective, given the minimizing of costs. This is a similar outlook for that came out of a study by Norm Normand, looking at the military aspects of the north and how we would protect the north and provide surveillance. And again, in his notion, these same gateways are actually used, but he adds 3 more to the north at Tuktoyaktuk, Navissivik, or 2 more at Navissivik. And his vision is of an airship that would continuously be flying between these locations, carrying goods to and from the various locations. So again, from the perspective of surveillance and protection of the north, the airships have a role that's not just civilian. In terms of looking at the demand, one of the areas where we're going to focus on, because it's very hard to look at every community, there's 128 or 29 that were in the study, and of course all the various goods that are moved, we decided to focus on housing as one of the main issues, because it's such an important and difficult problem in the north. Now, this is a study from Statistics Canada that looked at the number of people in houses and the question of how many were short rooms. So what you can see over in the Inuit communities, is that roughly 40% of all houses are inadequate for the number of people who are living there. A great number of them are 1 bedroom short, but there's many that are 2 bedroom and even 3 bedrooms short. What this means is a house that maybe would be designed for 4 people could have 6 or 8 people sleeping in the living room. And also there's a constant flow of people there's no such thing as homelessness when it's 40 below. Either you have a place to sleep or you don't make it. And so there's a floating population that also moves between houses. The Métis population also has 10%. And of course, the First Nations have another large number, about 25%, that have inadequate housing. This is an area that obviously we need to do something about, and there has been a lot of study of it. I know this is an eye chart, but I'll try and walk you through it. The yellows or the colors represent the various gateways that we've talked about. Well, we've named them here, such as the Yellowknife Enterprise Gateway, Thompson Churchill, and so on. What we have is the population. So in the total, there's 105,000 people living in this area. There are 31,000 dwellings, but interestingly, there's only 24,000 of those dwellings that are occupied. The reason is that a lot of these have been simply condemned. The problem of the quality of these houses is such that many of them probably would be condemned if they were in some place where the need wasn't so great. And in looking at the literature, it basically suggests that there's a 40% rule, that of the number of houses we have, we need 40% more to serve the population that exists there. And that's without a lot of extra growth. That's just what we have today. So in terms of looking at this 40% rule and the potential for housing, we can see that there's a pretty substantial shortfall in all these communities. We have converted this into tons and distances to come up with the actual demand for how much material would have to move into these communities just to solve the current housing problem, not to deal with anything in the future. I'd also like to point out, you can see the persons per dwelling occupied, an average here, for example, in the Thompson area, almost 5 people per house is the number that's occupied on average. So you can imagine in small houses, that's a crowded situation. We use this data to go forward and look at, well, where is and how much demand would there be in these various communities? In order to do that, we said, well, okay, obviously the airship's moving more than just building materials, because there's a large amount of fuel that has to be moved in for vehicles and also for heating, as well as groceries, vehicles and other sorts of equipment, motors and boats. And of course, if we had airships, we would have some growth as well, just because of the lower costs. So we looked at this as being 20, 20, 20, and 20. And we use building materials as the base and gross that up to be 100% for the communities, with the assumption that this could be delivered over the course of 10 years. So this becomes our demand that we have now for over the 10 years. Part of the reason for doing this is the question of, well, can an airship system be viable? Our view is that you cannot operate an effective transportation system with only one vehicle. First of all, you have no backup if something goes wrong, but also it's difficult to spread your overhead costs if you only have one vehicle. And our assumption is that each of these locations, if they could support a fleet of 3 airships, then that should be a viable number for the industry to move forward. Obviously, the airships can move around, but that's a different issue. You want to have a base where you have continuous service. So looking at this demand for goods over the 10-year period, we have our total, the average consumption, in this case being 128,000 tons, and looking at trips per day from these different locations, because they are different distances. Enterprise is a much shorter distance than is the Yellowknife distance. So we could do this with one airship in this area and 4 in the other. The bottom line of all this is when you add up all the numbers, you end up with about 18 30-ton lift airships, which means that there's enough demand that you could have essentially 3 airships operating from each of these gateways and providing a viable service. Every one of these gateways would not necessarily have a hangar. There would be some communal hangars that would be used because you don't need as many hangars. But this gives you some idea of what the kind of demand is. And this is only to serve the remote communities. There is another demand, which is for the resource industries and mining. Before I get there, let's just talk about the economics of this. Here we have an example of a building kit for this house that was sent up by water. You can see the crates of the material that's there. It's about 15,000 kilograms in total that's moving up. You can see the costs over here for the truck from Ottawa to the Port of Montreal, then the sea lift, and then finally the delivery. And this is going to Cole Harbour. Total cost of $54,000 per house, and the approximate cost is $4 a kilogram. So those are the kinds of costs that we currently face in moving goods into the north, again, depending on where it's going and how far it's going, but that gives you sort of a benchmark to look at the cost of transportation. In this case, looking at the economics of the airships, obviously there's various kinds of airships. There's probably 20 or more airship companies in various stages of development, and each one of those would have different characteristics and so on, but they're all going to be somewhere in the same ballpark. So we use the airship model that we have, the Canadian airship, to look at moving this up. The airship lands vertically onto a landing pad, and once it's landed, then of course it has to shift if the wind changes to make sure the people on the ground are safe. This is a schematic that just shows the goods would be coming from the various suppliers, food, building, fuel, other to the terminal at the gateway, load onto an airship, and then out to another landing base in sort of the remote community or to serve the resource industry. So this is the model we're looking at and to develop our costs, and I'll come back and talk a bit more about that in a minute. This is a map that shows the costs that we have based on this model for a 30-ton lift airship. And remember the number of $4 per kilogram? Well, here we're looking at numbers that are nowhere near that level. In some cases, not even half that, and in other cases, 42 cents per kilogram. These numbers, by the way, are represented on the basis of 300 days of operation for the airship. Airships can operate pretty much the same time as airplanes. This is our contention. But in looking at this, since there's very little that's coming back out of the remote communities, these are all the costs of one-way trips. So the goods are going in and coming, and the airship is coming back in ballast or empty or perhaps with refuse for recycling. In any case, a non-paying load. So these are the costs of one-way trips. This is a 30-ton lift airship. Airships get much better as they get bigger. So if we move to a 60-ton lift airship, you can see that the costs drop quite dramatically in this case. And also what we're looking at is the costs of the airship are based on what would be factory level production. In other words, we're estimating what would be a more mature industry, not the first airship out the door that would be produced at a very high cost as prototypes are. This is based on the cost of airships that we believe would be in production. So this is our 60-ton lift airship. And if we move to the next level of a 100-ton lift airship, this, by the way, would be roughly the size of the giant Zeppelins. So roughly 800 feet or 20, 30 meters, whatever that number would work out to in terms of size. So we actually end up with this numbers, and you can see they're a lower cost still. It's worth pointing out that we've calculated these as freight rates, not as costs. So there's a profit margin built in to the airship. And to do that, we use what is known as an operating ratio. So this is very typical in transportation. You look at what are your immediate costs, your immediate expenses, and then you have to add something for all your overheads and other costs and reinvestment. So in this case, it says that 20 cents out of every dollar would go towards maintaining the system and the overheads and reinvesting in the equipment. Depreciation is not included in that. So giving that percentage, and by the way, just to give you some other notions, the operating ratio for trucking is about 0.95. Airlines operate somewhere between 9 and 0.85. Railways can operate as low as 0.65. So depending on the mode of transport, the operating ratios do change, but this has profit built into it. So I think what it says is very clearly airships would be profitable to operate in the north. Just to summarize this and look at the impact of costs and distance. These are the various sizes of airships from 30, 60 to 100. And the distances we have are 250 kilometers and 500 kilometers. And what we can see is what you would expect. The further you have to go, the more it's going to cost. But it's going to be much greater difference if you have a small airship than a large airship. So obviously the pressure towards moving to larger airships in transportation is critical. But at the same time, we have to recognize that some of these communities are only 400 people, and therefore delivering something with a 100-ton lift airship might not be appropriate for the community itself. So you need to look at the size of airship relative to the market. But certainly for the mining industry, the 100-ton lift airship would be what you'd want to move to right away if you could. Speaking of mining, this is a slide which I know our next guest speaking is probably going to be using this too, and I apologize for stealing any of your thunder, but it's such an important diagram that I wanted to put it up because it represents the issue of critical minerals, and this is coming from the Canadian Critical Mineral Strategy, which you'll be hearing more about. We have lots of identified locations for mineral deposits that are valuable, and especially in the critical minerals of nickel and cobalt and copper, rare earth minerals, and so on. But what you'll also see is many of these are located where there are no roads. In fact, the road system more or less ends in a sweep like that. So roughly 70% of Canada's landmass has no roads. And it's pretty certain that there's more mineral deposits in the rest of this area that just haven't been explored properly or identified. So there's certainly a future for mining in the north. Over here, we have one example, and the Strange Lake mine. This was presented at the conference last year, and you can actually see a recording on the website if you wish to find out more about this mineral deposit. Their notion is to use airships to move from Strange Lake to Shefferville, and then the rest of the journey will be by rail or marine to the processing part. So they're looking at concentrating rare earths at their mine and then shipping them out by air. This is 240 kilometers. One of the reasons for using airships is simply the cost of roads. And to build roads in this area, which is very difficult terrain, rock outcrops, muskeg swamps, a lot of water crossings, as you can see in the diagram. And it is a very expensive process to build. Even gravel roads in this area would be somewhere between $5 and $6 million per kilometer. So 240 kilometers, that's almost $1 billion in terms of the cost of building that road. Makes it pretty difficult to have a mine if you have that upfront cost being so large. The Canadian Mineral Strategy does have a provision for infrastructure. $1.5 billion is set aside But you can see that would be used up pretty quickly with only a few locations like this if you're going to bring them online. So looking for a less expensive alternative like airships is certainly, I believe, an important aspect of our future. This gives an interesting comparison of the value of these critical minerals. We put gold on here just for the sake of it. You have to divide that by 1,000 in order to even on the map. And this is a log scale, so you can appreciate how much different it is. You can certainly open gold mines using a winter road and flying it parts out with a small airplane, and diamonds are similar. The rare earths, 40% concentrate, are still very viable, and therefore this would apply to them. Copper concentrate, nickel concentrate, well, we're in the area, and you can, this is a better graph, you can actually see their values. They're certainly not as valuable, and therefore your pencil has to be a bit sharper in order to work this. But again, that comes back to the cost and the size of an airship if you're going to use airships. In order to look at the question of, does a road make sense or should we use an airship, we developed this model which simply looks at the ton kilometers that are being moved in the bottom and the total costs along the top. And obviously, if you're going to build a road, it depends how long it is. So this line can shift up or down depending on the length of the road, but it's basically a flat line. You only build the road once. Naturally, you have to maintain it, but the big cost is building it. Once you have it built, well, the trucks are actually relatively cheap. So the cost of trucks is low, and it's just a function of how many ton kilometers you're moving. Adding these two together, you get the combined cost of the truck and the road. And the airships, of course, are just a matter of how many airships you're going to use and how many tons you're going to move. So this is simply a vertical or a straight line. Where these two cross at X tells us which we should use. Anything less than X would be less expensive to operate with an airship. Anything to the right, you should build a road. So it depends on the circumstances, and this gives us the model to look at what would be the direction. So in doing this, we looked at the Strange Lake case because we have some data from that project, how much they're going to move, the length of the road, and other issues, capital costs that we've put in. So this is the base case using trucking. It'd be some 10,000 trips to serve that mine. And you can see there's road maintenance, annual trucking costs, but the big cost is, of course, building the road in the first place. In order to compare this with the airships, we use the process of benefit cost analysis, which allows for the question of when are the investments made at what time, and how would that work out compared to an alternative, which has maybe different amounts over a different period of time. So the net present value gives us the value, if you had to spend it all today, of running this for 20 years. And in the case of the road, it works out to some $900 million. In the case of an airship, for the same amount of service, it's $755 million. So certainly in terms of the costs, if you just look at the nominal costs for the road versus the airship, you might be confused and think, well, the road is cheaper. But if you look at the value of time, the airship clearly comes out better. Now, this is for a 30-ton lift airship. If we move to a 100-ton lift airship, there's fewer trips, clearly, fewer airships, and now the cost drops dramatically. So bigger is certainly better in the case of airships, and dramatically so in the case of mining. So this is our first analysis, sort of a base case. We said, well, okay, let's look at some sensitivity. What happens if the costs of the airship are higher? What if it's 50% higher for the airship? What does that do in terms of the road versus the trucking example? Well, this is the example. We can see that it's almost now a wash between the 30-ton lift airship and building the road. If you increase the cost of the airship by a full 50%. In the case of the 100-ton lift airship, again, it's only about half, so not quite as sensitive to the change in costs if you're a much bigger airship. The next question we asked is, well, what if the mine is bigger? Because again, the total amount that you're moving determines where that X is between using airships or using the road, and volume really matters in terms of this, because once the road is built, you can use it essentially as much as you can. I don't think it'll ever become congested for mining. So here are our answers. And if you increase the mine out by 50%, it comes out that now the mine and the road is marginally better than the airship. There are some other reasons why you still might want to use the airship, but certainly in terms of just straight costs, for the 30-ton lift airship, it's not as good, but for the 100-ton, again, it's dramatically better. So these are, again, costs that we look at as 50% utilization. In other words, we're not looking at anything coming into the mine, and it would come in by truck or come in by airship. So in terms of the comparison, it doesn't make much difference. But if we're looking at the cost per ton, and someone in the mining industry is looking at this now, you'd have to recognize that anything that comes in on the return trip would reduce the cost of the outbound materials, or you'd share the cost, another way of putting it. So our study findings. First is that, yes, the remote communities have enough market to support fleets of airships. They're not huge fleets, 3 fleets for each place, but that's certainly enough just for the remote communities to move. And we recognize that it wouldn't just be serving remote communities. If the airships were there, they would also be serving mines. And this might be very advantageous because the amount of goods coming from the mines south would be much greater than the amount going into the mines going north. So there'd be capacity to also take goods to remote communities, drop those off first, and then go to the mine to pick up concentrates to come back. So the two are complementary, they're not competitive. Certainly, we recognize that the airship freight rates will reduce the cost of everything in the north. And we've talked here a lot about the housing, because it's a really critical issue and it's very visible. But food is 2.5 to 3 times what we pay here in the south. Even with subsidized freight rates, it's much higher than what we pay. And of course, other materials, furnishings, vehicles, everything that's required from the south has to come in, and typically only comes in these very short periods. We identified 9 gateways that connect the north year-round. And I guess this is a bit of exaggeration. Iqaluit isn't year-round. It would have to come from other gateways during the time the ships aren't moving. But certainly, we would have continuous service year-round. This would have other benefits I won't go into, but such as the issue of training people to build houses in the north. If you have enough activity, then you can get qualified to be a carpenter, electrician, or a plumber, and what have you. Some of the implications for the study. Well, certainly for government, this is a guide to the infrastructure. Where would the transshipment spots logically be located, and how much investment should be done to work that? What regulations are necessary? If we're going to have an airship industry to serve the north, we need a regulatory framework. And finally, the question of economic development, how this would benefit such things as the critical mineral strategy. The gateway locations for them, well, it's an opportunity to enhance their economy. There's gateways always benefit from the movement of goods, the storage, warehousing, handling, and other activities that can occur at gateways. So for these communities, certainly there's an opportunity for them to enhance and make their communities more sustainable. For the mining industry, obviously the clear point is the access to deposits that are already well known. They just cannot be accessed because of the cost of building infrastructure to reach them. So these stranded deposits would now be able to come into play. And for the communities, hope for lower prices for food, for housing, for everything they need, and an opportunity to be more engaged in terms of also producing things in those communities that they can have jobs and ship things out. So opportunities for the communities are clearly the driving factor here. These recommendations, and I'll end with this, these are the recommendations of the study. The first is that the government of Canada needs a clear policy statement. Are they going to support airships and the cargo use in the north with the Shield and the Arctic? At this point, we don't have a clear policy statement as to where the government stands on airships. Do they support them? Do they want to help this industry move forward? Transport Canada does have one employee who deals with airships. Andy is, I believe, on the line because I spoke to him yesterday by email. But we need a dedicated employee that is the liaison for the airship industry to help move this forward. How is it going to, an advocate within the government, I guess I would say. Another idea we have is Canada should consider an X Prize award. There are a lot of airship companies that would like to serve this area. If we had some kind of an X Prize that would help to stimulate investment and encourage the airship companies to take a hard look at Canada, this would be a good way to move forward. Clearly, the airship industry needs to have people who can operate airships and maintain airships. We need a proper curriculum to do that, and we need some focus on Indigenous students. The people in the north should be the ones that are operating the airships in the north, and so we need more people from the First Nations and Inuit and Métis to actually be operating the airships. And finally, if we're going to have airships in the north, they have to be able to survive in the north. This may seem like an obvious point, but it isn't necessarily clear that any airship today, whether it's on the drawing sheet or it's in some kind of prototype production, is actually capable of surviving at 40 below. We hope that's the case. It should be the case, but until you actually do the test, you don't know. And so one of the things that we've been working on here in Manitoba is the development of a location for cold weather testing for airships so they can be used in Canada and in the rest of the area. So with that, I will stop and I will open the floor to Kelsey. I don't know if any questions have come in through the chat, Kelsey, but over to you now.
Great, thank you. So we do have about 14 questions, but just keeping an eye on time, we're already almost 15 minutes into the next session. So Barry, how would you like us to proceed?
Well, you know, why don't you ask one burning question and then we'll proceed to the next session.
Okay, so I'll try and summarize. There were several people that asked about things like weather and wind and infrastructure and support from Indigenous communities. So all of these issues that are particularly salient in the north. So how have those factors been incorporated into the study that you just presented and into kind of planning around airships for the future?
Well, I think using the first one last, the support from the north is pretty clear. And it is not every Indigenous community really has had a chance to learn about airships. I mean, the only way we find out about them is through meetings like this one. So it isn't always clear that people know what is possible, but certainly the word is getting out. And what we see is a very substantial groundswell of support. With regard to the weather and climate, there have been airships in the north in the past. I mean, the Zeppelin did fly there. The Norwich was the first airship across the North Pole, or sorry, first aircraft across the North Pole. And so we have some experience in the north, but operating there continuously is maybe different than operating once in a while for a trip. So we do have to do the research and the testing, but there's no reason to think we can't do it. So Kelsey, again, thank you for that. I'm sorry, everyone, for not answering more questions. Maybe I was a little too long-winded, and that does happen. But I will turn this over to Kelsey to chair the next session and introduce our next speakers. Thank you.
Okay, thank you, Barry. So for this session, which is on the northern demand for airships, we have 3 different presenters who will each have about 15 minutes to deliver their comments. In the interest of time, it may be best if you direct your questions directly to these speakers, maybe via email or in the chat at a different time during the session. So first today we have Andrew Ghattas, who's going to discuss critical minerals and development opportunities. Andrew has over 15 years of experience working in policy with the Government of Canada and is currently the director of the Critical Minerals Centre of Excellence in Natural Resources Canada. So Andrew, please go ahead.
Hi, everyone. Thanks for having me here today. I'm just going to turn this into presentation mode and I'll whip through it pretty quick. So I think Barry had a great setup overall in terms of critical minerals, this opportunity in the north and the linkages with infrastructure as we kind of view this file in a really holistic manner in terms of how we're going to advance the development of critical minerals overall. So I'll get into a bit of the critical mineral strategy and just also into some of the programming and that I think is most relevant in this space to give you a sense of how the Government of Canada is proceeding in this area. So critical minerals are essential to the clean energy transition. So critical minerals are essential to this overall energy transition, whether it's movement to solar, wind turbines, small modular reactors, hydrogen. Critical minerals are essential to that overall transition. And you're seeing the demand really grow for some of these minerals, particularly in for example, the battery space, whether it's nickel, graphite, cobalt, magnesium, lithium, they're increasing significantly. So that those slides were in terms of the cost relative to gold, they're in flux at the moment. This is a generational economic opportunity for Canada. We have critical mineral deposits located all across the country. We're all an extensive mining nation, have been doing this for a long time. So we have the know-how, the skill set, infrastructure in different places. And so this map just kind of highlights some of the regional opportunities. It's similar to the one that Barry had in his presentation, but it takes a bit more of a regional approach as we kind of figure out where to concentrate some of our activities. And this really only depicts what we call advanced projects. So this doesn't even really take into account the potential, particularly in the north, where we know there's probably vast deposits of various critical minerals. But overall, this is a huge opportunity to kind of stimulate economic development as we make this overall transition to the green economy. Part of this overall, the strategy and part of the drivers in this space are driving a broader industrial transformation as we kind of move from change our industrial base to be able to meet the demands associated with the clean energy transition, and also in the face of supply chain reorientation. Obviously with COVID-19, there was a lot of scrutiny placed on supply chains, particularly the concentration of supply chains and manufacturing in certain locations that make supply chains more vulnerable overall. And so as we kind of look to the future, we see this opportunity of just building out manufacturing potential, linking the critical minerals into the processing, into the final manufacturing, both in Canada and with trading partners to secure that value added. And we're really focusing on the clean technology manufacturing, advanced manufacturing in terms of the materials side, as well as things like semiconductors. Canada has all the minerals and for these areas. So the Canadian Critical Mineral Strategy, this was launched in December 2021 by Minister Wilkinson. It's really focused on 6 overall objectives, or sorry, I should say 6 overall pillars of the strategy with 5 kind of core objectives: supporting economic growth and competitiveness, job creation, promoting climate action, environmental protection, and as well as fostering diverse and inclusive workforces and communities, enhancing our global security and partnerships with allies. So these 6 pillars kind of encompass all aspects, not just of the mine development itself, but also the things around the supply chain and the critical minerals that are going to allow it to grow and thrive in the future. So as part of the strategy and the overall commitment in this space, the last 3 federal budgets have announced significant funding to implement the strategy. Again, it started in 2021 and went into 2023. So about the big signature initiative was in 2022 with about $3.8 billion allocated for a range of initiatives that kind of span span all of the areas that were noted. So starting at things like geoscience, going into R&D, Indigenous capacity building, regulatory supports, infrastructure, which I'll get into in a little more specificity, different forms of tax credits, how we position ourselves on the global stage, supports across that kind of gambit of activities to take a really multifaceted approach to how we view this. It's not just one thing that we need to do. We need to kind of be involved in multiple areas. And so that's really how we're driving this forward in a kind of a cohesive manner by making sure all of these different parts are linked. So I want to get into a few of the specifics initiatives associated with the strategy, and I tried to narrow it down because there was quite a few to the ones that I thought were most topical to this conversation, on the infrastructure component. But I'm going to start with the Critical Minerals Concierge Service. So this is part of the overall objective of accelerating project development. It's really focused on 2 aspects: how we support industry navigate the regulatory processes, and oftentimes that goes beyond just the mine development itself and takes into account other regulatory issues. I think it was well noted. How do you actually access some of these rural, remote, northern deposits? That is oftentimes the economic block in terms of their development. It's the access side. You contrast that with other mining jurisdictions like Australia, and where they're mining in the outback, it's quite simple to build a road. I mean, you can't even compare it to a Canadian context, the ease. And so there's obviously that kind of brings in a large regulatory consideration as well as you kind of advance that, have that consideration. So the concierge service is here to help firms more at the micro level in terms of navigating the regulatory process. There's other things underway at a more, macro level in terms of the overall regulatory framework, but this is where we're trying to assist firms kind of through that. We're also, obviously there's a range of federal support measures, which I'll kind of conclude with, and we're here to also help firms kind of navigate that landscape as well. And that can include the infrastructure components in addition to whether it's R&D supports, again, more focused on processing and mineral extraction as per the strategy, but we get into working with our infrastructure partners and some of these components as well. So I just wanted to start there just in terms of where we're at. One of the signature initiatives of the budget 2022 was targeted supports through the Strategic Innovation Fund. So this is a flagship program from the Government of Canada that provides a lot of supports for industrial development. So $1.5 billion in that area, really focused on developing our processing capacity in this space. Obviously, the CapEx associated with building a nickel sulfate processing facility or a lithium hydroxide facility, rare earth magnets are huge. So there's some targeted supports coupled with some tax credits to really stimulate activity in this area and to provide a home base. So if we do develop the minerals in the north, they actually have a place that they can be processed within Canada, maybe a little bit further south, just in terms of other supply chains. But it's really a bit of the anchor point through which we kind of develop this and help connect some of our northern economic opportunities to further manufacturing in different parts of the country and maybe overseas as well where needed. So this was captured in Barry's presentation just in terms of the infrastructure component of the strategy. So $1.5 billion had been announced specific for critical minerals infrastructure, and this is really to help unlock priority deposits across the country. We're really focused on 2 tracks here as the program just kind of gains some steam, and we have to go through some internal processes, but it's really focused on transportation corridors. So how do we again link the mine sites to supply chains and transportation corridors wherever they may be for export markets or internally for further processing. And then there's obviously there's a clean energy component to this as well, in the sense that Obviously, not a lot of our northern locations are not connected to the grid. They rely on diesel. So we find ways to, provide a mix of clean energy technologies in those locations, wind, solar, and maybe another forms, small modular reactors over time. Those aren't quite ready at this point, but those are kind of the two conceptual approaches we're identifying. And also looking at how do you build this infrastructure in such a way that there's multi-user benefits. So I kind of liked the concept that was shown in the first presentation, just in terms of how you're servicing both the mine site and also the communities. And there's the both benefit, one obviously being the economic driver and one being almost the regional economic development and the community support. So I think that's a really nice pairing and something that we're trying to really promote through that particular program overall. So this one will have an official launch date in the fall after some internal work gets finished, but this will be a key one. I think this is all just in relation to some of those topics. There's also supports, particularly for Indigenous peoples and how they kind of are involved in the critical mineral space. And that helps to help build out their capacity so they can engage in projects. So again, I see a linkage here too, in terms of some of the thought process given where the labor force often is for some of these operations, mining operations. You need different skill sets and different training, and in areas that maybe we don't even actually have the labor pool right now more broadly in Canada. So another just linkage. And so there's 25 million within an $80 million pot to support Indigenous peoples and training and participating in critical mineral development. The last slide here is just more our support framework for critical minerals. And again, we recognize that kind of firm needs in this space are quite diverse. Sometimes it's more early stage that needs more support on innovation. As a firm grows, it looks at different aspects. But why I really wanted to bring this one forward is because of the model. And ultimately, we're working with the Canadian Infrastructure Bank quite closely on these projects, in addition to the Critical Mineral Infrastructure Fund. And so these work in tandem based on the size of the project and the specific needs of firms in this space. Because we don't just view it as, you can't just develop the mine, you have to develop the things around it to actually make it economically viable and over the long term. So we're trying to bring as many of these tools to bear and look at things in the most holistic manner possible to ensure that we're successful in really driving this forward in a Canadian context. So I'll stop there. I'll know we're a bit short on time, and hopefully that wasn't too quick. And I'm more than happy to share the presentation with everyone and have follow-ups by email or through the chat on a separate course. Thanks, everyone.
Thank you very much, Andrew. Next, we have Ross Prentice, who will be talking about housing demand. So Ross has a strong background in transportation with about 20 years of experience in the intermodal transportation industry, as well as a professional designation in logistics, and he is currently the CEO of BASI. Ross, please go ahead.
Thanks very much. I'm just going to share my screen here. So I'm here today to talk to you about how the CMHC is working to address the growing problem in Canada's north and how BASI fits into this. Canada's northern housing network is way over capacity. The stats show basically that 20% of Indigenous people in Canada are living in overcrowded housing. This number is even worse if you go further north. As Barry showed in a previous slide in his presentation, more than 40% of the people of Inuit descent are living in overcrowded housing. This is a huge problem as it creates a lot of difficulties for the housing network. Houses degrade very quickly due to molds and premature wear from being overcrowded. As well, these conditions can also lead to health and social problems. So it's more than just the crowding itself. And if you look at this, this is information we recently collected. There's a housing developer in Nunavut that was explaining that it's costing $750 a square foot to produce houses up there. And this compares with the average for the national average of the southern communities of about $170 a square foot. And so it's clear looking at this, just why spending more money isn't helping the problem. you've got a huge problem to overcome at 4 times literally the cost to build up there. So CMHC in 2022 issued a challenge for housing supply for remote communities. They're looking for novel solutions, trying to figure out ways that they could help to reduce costs, take novel approaches, do other things to be able to allow for this to be solved. They're deeply involved in this. They spend a huge amount of money every year in the North building houses, so they really understand the problem. And they selected BASI among 33 other shortlisted applicants to be able to provide a solution or bring forward a solution for this problem. I've taken and I've put the people all into different ecosystems to get an idea of sort of different ways that it's looking to be approached. The first that you can see in the top corner here is we've got building and warehousing, and that building, warehousing, and increasing retail capacity, rather, sorry. And that essentially allows for the capacity to be there at the time that the people are looking to use it, and as well to increase the overall storage capacity that they have to be able to hold some of these things and not have damage over the course of the year. Another group is looking, or this other group here is looking at doing training programs and policy development. This is going to help to be able to ensure that there are trained people in the locations where there's necessary, as well as adjusting some policies about the way they approach things for some of these communities so that they'll have a better chance to have an overall economic benefit from it. And then as well, those that are looking to create products closer to the need, so to reduce transportation costs by having those things available closer and by building them closer and involving the community as well. And then finally as well to the transportation and infrastructure pieces, and that's where BASI comes in. So we see airships as a year-round transportation solution, supporting all parts of that ecosystem that I just referenced. The intention for our design is to build a robust airship that will be able to withstand weather that anything Canada can throw at it, we're going to be able to handle it. There's a certain reality to be faced about wind and high winds that we're certainly going to have certain amounts of time where we'll limit our operations, as there are just no aircraft that are going to survive in those scenarios. So we have to be a little bit careful, but we're optimally looking at 300 days of operations, similar to traditional fixed wing aircraft. So airships are going to help up in the north with the growing population up there. They'd support industrial growth, allowing the increased warehousing and retail opportunities to actually thrive up there properly. With reduced transportation costs, every dollar also stretches just a little bit further. And I think that's very, very important in terms of aligning with the goal that BASI set about 10 years ago, which was to have northern milk available at the same price as in the city. And this is only attainable if you can reduce the cost of transportation for those products. The regular delivery of materials also allow tradespeople to earn their Red Seal tickets. This is a really critical piece in terms of reduction of cost, not because the labor would be necessarily less expensive, but that the labor would not have to be transported back and forth continuously all the time and housed, which of course also creates a tremendous amount of additional cost beyond just the paying for the actual skilled trade. And as well as the activity in the area increases, this is a chance to have supportive services and service offering type jobs that develop. As well, the airships themselves and air bases will also need skilled staff to operate them. Airships are going to allow remote suppliers to extend their reach tremendously. So even if you're building something that you're going to a northern point, you're going to build something somewhere that's closer to some communities, there's still going to be lots of communities around that you could serve that you really just kind of can't get to because of the existing infrastructure. Looking at airplanes, they just don't have the capacity to be able to carry large objects. So if we're building anything where there's multiple panels connected together or a larger object, it's literally impossible to use airplanes for it. And so as a result, airships would be in this case able to support these initiatives for new buildings closer to communities by providing additional supply and delivery options. As well, the building costs themselves will be reduced. Airships can deliver just straight up more things for less money than what we can with traditional modes of transportation. Bulky objects, like you can see these septic lines in the picture here, they take up a lot of space relative to their weight. So having something like an airship, which is very volumetrically efficient, is really appealing because you can move a lot of that stuff and it ultimately doesn't change your cost. And then, yeah, as well to the continual deliveries of material allow for projects to be held on a steady plan instead of it being something where you have to wait to see if the winter road's going to come in and when it's going to come in, and if you're in line with a bunch of other people for materials, etc. There's all sorts of things. So the steady flow of materials all year long as well too also gives those communities the opportunity to capitalize on times when there are lower prices rather than just being stuck with whatever the price is at the time they're trying to buy. So the Canadian Airship Transportation System would essentially allow for communities up in the north to be able to have airship service on a regular basis. BASI is looking at and working with several different communities at the moment to try to develop this idea, and ultimately there's a desire for a huge amount of Indigenous involvement in this. We're working with EIC and Comair, who are both very experienced Northern Canadian air operators and have lots of relationships in the north. There's a desire to develop a system that would be owned and operated by Indigenous communities in the north. We've worked with CMHC to leverage some of these relationships and aid the development. So here I'll show you just briefly our landing system. This is something that's going to be very important in terms of being able to handle the airships both safely and efficiently. So we want to be able to transload quickly. We don't have to worry too much about the wind moving us around when we're on the ground. And as a result, the development of a turntable is something that we've looked at to be able to allow for us to be able to have the aircraft move on the ground while winds are changing and still be able to continue to load and unload and carry on operations as though there wasn't any. This is also an opportunity for us to exchange ballast, to refuel, adjust gas supply. There's a bunch of things that this will be able to do for us. And as well too, it keeps the movement of the aircraft in a careful and controlled way away from things where it could possibly bump into them. So we've looked at an initial housing move. We've got several that we've got planned, but I'm going to show you this example here. We're looking at the Moose Cree Gateway. They essentially are in an ideal position to serve a lot of different communities. We've got a very strong railway connection with the Ontario Northland Railway. We'd be able to bring in goods and transship them to Airship from there and make deliveries all over the place to remote locations. Returning with a combination of ballast materials. This could be recyclables and garbage, waste materials, water, all sorts of different things, rocks, mining materials, whatever is available. Ultimately, the airship has a continuous lift, and in the case that we're looking at here for 30 tons. So if 30 tons of goods are coming off, 30 tons of stuff has got to go back on. So for our part of it, we see a tremendous opportunity for industry to develop. And again, it's a big piece of what we're looking at there. So the service, just as again, this is a potential service, so nothing has been fully established, but we've identified 14 communities that are within the 600-kilometer range, which is about the serviceable economic distance that you can use for an airship. Within that range, there are 18,000 plus people. The weighted average air distance for those people, it's 283 kilometers average per person. There's a weighted calculation in there, but based on the amount of people and the distances. In order to be able to do this, we'd look at an operating cost annually of about $52 million, which would net an annual profit of about $10 million and provide a sustainable freight rate to those using it of about 66 cents a kilogram. To give some frame of reference, the typical air rate right now is about $2 a kilogram. So it's about a third of the price. Obviously not quite the exact same service, but still air cargo and a fraction of the cost. So in order to be able to accomplish this, the fleet that would be needed is about 3 airships. We look at this as a need because you want to be able to have service reliability as well as critical redundancy in case of situations where you've got weather that prevents you from carrying on your service for a period. Again, we know that Canada can be quite extreme at times, so there's going to be a need to have a certain amount of redundancy in there to be able to account for any kind of shortfall that we might encounter. We need about 15 of these landing bases, one for each community, as well as one as the hub point transfer station at the gateway. And this would, again, allow us to be safe and predictable in terms of how we go about unloading our freight and loading things on, allow for efficiency. And then as well, we need to have one piece of hangar infrastructure. This would allow for any service or repairs to be done, as well as any periodic inspections that the aircraft might need as it carries on. And this is a basic breakdown of the way that the costs would be broken up amongst different sectors for us. So ultimately, you can see here the aircraft purchases a significant portion of it at nearly 30%. The actual machines themselves are really the most expensive aspect of operating these in general. But there are also other costs. If we look at the hangar and landing base costs together, they make up about 13% or so. This is an area that we see government potentially having a role. So it's certainly possible that the structure of the operations costs would change somewhat, again, depending on how much government involvement there is. And as well, there's some included costs here for fuel maintenance, staff, and insurance as well. So just to give you an idea, the maximum capabilities of an airship service using what I just described there in terms of the infrastructure pieces, we'd be able to accomplish about a little over 2,600 trips a year. This would net close to 80,000 tons. Seeing communities basically 3 times, potentially sometimes 4 times a week in some scenarios. Again, this is a maximum. I don't know that every community would need to see an airship that often to be able to be supplied. And then as well too, we'd be able to move the equivalent volume of 93 houses per community each year. Again, this is capability only. I think as Barry had mentioned, and we've kind of done some previous studies, about 20% of the materials are likely to be building materials. So if we look at that number, I'm sure 18 houses in a year would be very welcome in a lot of these communities at this time. So with that, I'll say thanks very much for your time, and open it up for any questions if we have time for that. Thanks very much.
Yeah, we have about 2 minutes for questions. If anyone from the audience has one, I'll check in the Q&A. Now, one person in the chat did ask how you build the bards. You'd mentioned those platforms. That might be an easy one for you to address.
Certainly. Yeah. So they're essentially like a giant pie. So we have huge pieces that all fit together and create that ring that we have. And it's connected all on a track and rail below, where there is a wire system that operates through. So it's cable driven and has a big base underneath that essentially has a cable wound through it and then over to a motor along. And that's connected to some very specific technology that tells us what the wind is doing, what it's likely to be doing, and allows for us to be able to ensure that we're orienting the aircraft correctly at the time. Does that answer the question, or is it, well, there may be more follow-up?
Thank you very much.
Cool.
Okay, perhaps we should move on. But if people have additional questions, feel free to throw them into that Q&A tab. And then
I can answer them in the chat as well too.
Perfect. Thank you so much. Great. So last but not least, we have Gage van Alstyne from Gillam Aviation Fuel, who's going to talk about airships for northern transport. So Gage grew up in northern Manitoba and is the owner of several businesses in the tourism and supply chain industry, and is interested in how new technology can revolutionize the north. So Gage, please take it away.
So hello everyone, thank you for having me. My name is Gage van Alstyne. I'm a multi-business owner throughout Manitoba, including the north. My parents moved up here in the 80s and I've lived here ever since. I have a lot of experience in the logistical world of remote transportation and the challenges we face here in the north. I'm working with community leaders, housing initiatives, and mining companies on new solutions to solve many of the obstacles we encounter living remotely. I understand the barriers to entry for many businesses in northern Manitoba, and I hope to share with you some of my analysis on the airship business from the perspective of the end user. So part of conducting business in remote communities in Canada is the necessity to build genuine relationships with its leaders. Through this presentation, I hope to shed some light on what I've learned from my discussions with the leaders and how the airship business could solve some of the challenges that these communities face. So what are the problems? As some of you might already know, transport is the main challenge in bringing goods into remote areas. Goods are either transported by winter roads, sea freight, or air freight. All three of these options are costly, not always reliable, and can be limiting based on weight and weather. Furthermore, due to climate change, these forms of transportation have been drastically affected. In the last decade, the availability and reliability have diminished, and our northern communities are suffering. As you can imagine, the Earth's temperature continues to rise, which shortens the winter road season and creates unpredictable sea and weather conditions. This is only going to get worse as the years go on. Our communities are desperately needing another solution for transportation of goods. So let's dive into this a little bit further. So fixed wing aircraft. For some remote communities, smaller aircrafts are the only option to bring in supplies and goods. These smaller aircrafts are great for bringing in groceries and smaller machines. However, larger items are not an option. The air freight is not adapted to oversized and overweight goods and remains very expensive. Winter roads. For a business, sustaining operations in the north requires a significant amount of planning. Planning a few seasons in advance is necessary to ensure that proper materials are delivered in a timely manner. From my experience, building materials to these northern communities need to be planned 6+ months in advance to be ready to ship on a short winter road season. If the road closes early due to the weather, items don't make it. If crucial building materials were forgotten, houses don't get built. If something was damaged on the treacherous winter road, items don't work. These are all devastating and real-life problems that remote communities members face every year. In Manitoba and northwestern Ontario, over 5,000 kilometers of ice roads are built every year. If stretched out and linked together, it would be the equivalent of building an ice road from Montreal to Vancouver. These ice roads serve a population of only 50 to 60,000 people and located in about 3 dozen northern communities. Building 1 mile of ice road for every 20 residents is a large annual drain on the treasury. So we cannot afford to replace the ice roads with all-season gravel roads. I'm not sure if any of you have traveled to northern communities, but it is not like building a road in the south. On average, gravel roads in the north cost $3 million per kilometer. To convert Manitoba's 2,400 kilometers of winter roads to gravel would cost $7.2 billion, and to convert Ontario's would add another $9 billion. As you can imagine, there's room for a better solution. So getting back to climate change, warming temperatures are a mixed blessing when it comes to transportation. Greater melting of the polar ice cap is extending the marine shipping season, but also increases the melting of the permafrost during the summer. This threatens to damage existing roads, landing strips, and other infrastructure in the north. As the winter warms, the ice roads are becoming less reliable, and the end economic use of ice roads is already visible in the central provinces. The issues caused by climate change to the roads increases the urgency and therefore interest from the northern communities to consider other transportation solutions. Perhaps a cheaper alternate is a cargo airship. They could deliver large loads frequently throughout the entire year, as well as provide less expensive transportation for community residents. So groceries. Many community members supplement their diets with hunting, fishing, and living off the land. However, it is not possible to live entirely off the land. Therefore, groceries continue to be essential for northern community members. Due to the difficulty in transportation, the cost of groceries is now 2.5 to 3 times the price in the cities. With food inflation, prices are at all-time high and continue to rise. The produce that communities receive can be astronomical in price and near rotting. So while many northern communities enjoy hunting and fishing, there are high costs included with this as well. The cost of snowmobile, ATV, boats, fuel, all have high transportation costs to get these items to the communities. Inadequate transportation affects the quality of life, the health and well-being of the community members. Having lower costs for shipping of all goods would lower the cost of groceries as well. Not only will airships help lower the cost of groceries, but also help lower the costs for hunting and fishing. So fuel. Currently, most isolated northern communities' power supply is provided by diesel generators, which require a massive amount of fuel each year to run. The winter roads supply the communities with fuel, but as previously mentioned, with the challenges of the winter road construction and costs, the fuel is at risk of not being delivered. When fuel is not delivered via winter road, it is then brought in on a fixed wing aircraft, which increases the cost to $4 to $5 per liter. This unexpected increase in cost can be devastating to many community members. So housing. The housing in northern isolated communities is substandard due to the high cost of transportation and the lack of building materials in the communities. These buildings and homes are not maintained, are overcrowded, and are in short supply and high demand. We believe with a new backbone and supply chain costs, transportation, the cost of all goods and services will decrease and the well-being of all isolated communities will increase. On APTN, a TV network, there was a show about a northern community that was on the coast of the Hudson Bay. In the show, they demonstrate the excitement of the community upon the arrival of the ship. The ship is transporting community goods such as fuel, building materials, vehicles, dry goods, and a taxi cab, which the community desperately needed. This show perfectly demonstrates the issue of transportation and delivery of goods to remote communities. This one community receives their bulk goods in a very small window in the year due to seasonal changes with the ice. A similar scenario for a community that relies entirely on short winter road seasons. So I've been working in partnerships with builders and architects on new ways to build residential homes and commercial buildings that are prefabricated kit homes. These homes will work in tandem with airships and create a perfect marriage between the two. The airships will have the ability to haul large, heavy loads, while the concept building methods have the ability to stack prefabricated building panels ready to be constructed on site by trained community members themselves. These homes will require a trained tradesman, which will provide jobs, who we plan to train in each community to be the labor force in constructing the buildings. This concept idea is in phase 2 of development, and real models are being constructed in winter of 2023 and 2024. So mining. Canada's landmass has many mining opportunities that are difficult to explore and extract due to the lack of infrastructure. With the global demand for mining on the rise with green energy, Canada is positioned favorably with many unexplored regions. The challenge is logistics. With revolutionary transportation vehicles such as Airship, economically unfeasible mining areas may become feasible with the ability to avoid developing roads and train tracks to access the mine for exploration purposes and also operation and extraction phases as well. The current challenge with the mining is the environmental and land rights. In developing the roads with airships, this can all be avoided. So in summary, airships can solve these challenges by significantly increasing the shipping season to 300 plus days a year to all communities and not just coastal. Additionally, each northern community will benefit from the synergies created from transportation jobs and lower transportation costs. Small businesses would most benefit from the lower cost of goods as sold and more active workforce. A new generation cargo airships would have a revolutionary impact on northern transportation and logistics. Transportation and logistics costs would fall and the problems of environmental regulations would greatly diminish. The airship may be the only means of transport that can mitigate the negative consequences of climate change in the northern transportation region. That's everything. Any questions?
Hey, thank you very much. So as of right now, we have one question for you in the chat that asks about thoughts on solar hydrogen being stored instead of diesel. I'm not sure if you can speak to that.
Unfortunately, that is not my subject matter expert, and I cannot speak on that.
Okay, thank you. Any other questions for Gage? Okay. So seeing none for now, I'll leave that for people to follow up with you directly, Gage. So thank you very much to all of the speakers for your presentations. Our next session is on power systems, and that's being chaired by Dr. Paul Larson. So Paul, if you're ready, I will hand things off to you.
Thank you, Kelsey. That was very interesting. And I see Christoph is there. We're not scheduled to commence until morning, Christoph. We're not scheduled to commence until 10:30. Hello. So perhaps we'll just have a brief pause, and then at 10:30 sharp, Christoph, I'll start things off.
Okay,
You bet.
should I share my first slide or?
Yes, yeah, you would be welcome to put that up. Sure, yeah, that's a good idea. Yeah, so that we're all.
Well, I don't know there's any reason to wait. The people are here. Why don't we just go forward?
Okay, fair enough, Barry. Yes, the boss Dr. Prentice has spoken, and it shall be so. Yeah, so please, Christoph, let's kick it off here. By way of a brief introduction, if I may, Christoph is a professor of computational engineering at the Friedrich-Alexander Universität Erlangen-Nürnberg in Deutschland, Germany. His research includes high-performance computing and numerical simulation with respect to different engineering applications. In particular, he's interested in optical applications, simulation of solar cells, and of course, of relevance to us today, simulation of airships. He studied mathematics at Technical University München, and then worked at the also worked at that University of Würzburg, and the Lawrence Livermore National Laboratory in the United States, before his current position at Erlangen-Nürnberg. So with that, Christoph, please take it away.
Yeah, thank you very much for this nice introduction. I hope you all can hear me. My talk is about solar-powered airships. And let me start with a comment on climate change. Climate change is well known for a long time. In particular, there was even a cinema movie about global warming in 2006, which was called An Inconvenient Truth. But even before that, there were a lot of campaigns which explained that climate change exists and what kind of impact it has. And therefore, a lot of people, even more than 20 years ago, tried to make decisions such that we have less global warming. And for me, it was also about, I think it was about 2003, when I had a postdoc position in Würzburg, and I was thinking, okay, I have to go to a conference in Uppsala, and there were two options. I either could take an airplane and a train, which then cost me 7 hours, or I could take a train for the whole trip, and taking an aircraft would be less good for the climate. And therefore, at that time, I thought, okay, I should make a decision and use the train. And it was a comfortable train trip because there was a night train, and I had a lot of space for this trip from Würzburg to Uppsala. This shows that there is a large demand for climate-friendly aviation, and there's certainly a big market for climate friendly aviation. The question is, how can we come to climate-friendly aviation? And to this end, we first of all have to look to the impact of aviation to climate change. And interestingly, only 1 by 3 is caused by CO2 emissions, and 2 by 3 are other effects. By other kind of emissions, and the consequences is that we need zero emission flights. Yeah. However, the difficulty is now when you have a traditional aircraft, you can try to run this aircraft with hydrogen, but if you do so, you cannot transport passengers or cargo in a long distance. So a real zero emission transatlantic flight is currently not possible with traditional aviation. And therefore, when we have to look for alternatives, and my talk now is about how can we use airships when we want to use only solar and wind power. So with airships, everything is much easier. It's much easier to come to a climate-friendly aviation. The first airship which had solar cells on his surface was an unmanned airship built in 1992. It was called Lotte. And now we can think about, okay, what would happen if you would take very modern thin film solar cells, which are flexible and wide-lated, and when we would take modern batteries. And additionally, what would happen if we would cover an airship in the size of those which existed 90 years ago? There were 3 countries in England, USA, and in Germany. There were very big airships. Interestingly, for example, in USA, there was a USS Archon, which had a helium as a lifting gas. And one time it transported even more than 200 passengers. So what would happen if you would take one of these airships? What would be the travel time? What would be the optimal route? What kind of battery size should we use? And what should be the area of the thin film solar cells which have to be covered? Yeah, and we were taking in our analysis the German LSAT 129. So these were the sizes of the LSAT 129, and we assumed that we are using 6 solar cells. These are commercial available flexible solar cells. They are really lightweighted, only 0.5 kilogram per square meter. And now let's assume that we'll take a lithium-ion battery like we have currently in electric cars. So we would take 30, let's say roughly 30 batteries we have in electric cars, and we would use 4 electric motors with the power of the motors at that time. Here you can see now how many freight weight you can transport. For freight transport, you need only a low altitude. Such an airship could transport 60 tons. And for passenger transport, you could transport between 200 and 100 persons, depending on altitude. Yes, these are the values we estimated for passenger transport and freight transport. And what we wanted to take into account are real winds. So we took wind data from the year 2019, and we took the solar irradiance depending on day and time, and we developed algorithms for calculating an optimal route and for using the battery in an optimal way. So I don't want to go in detail now, but you need really several different kind of algorithms to optimize the path and also to optimize the use of the battery. And let us look to the simulation results we obtained. First of all, we looked to a trip from London to New York and back in March of the year 2019. And here you can see that we would have a different trip, different route, one direction and the other direction. And depending on the maximum altitude, the airship would sometimes have a flight height on a higher altitude or a lower altitude. It all the time would use that kind of altitude, which is optimal with respect to the wind. So the wind direction also changes with respect to the altitude. Here you can see now 4 flight paths for a winter, summer, and autumn. Spring, you see a green, winter is blue, brown is autumn, and yellow or orange is summer. And you can see that in particular, the trip from London to New York is a little bit more difficult because then in winter, the airship has a lot of problems. First of all, in winter, there is less sun. And second, there's all the time, or most of the time, wind from the front. And therefore, the airship is going to the south because there's much more sun. It can get much more power, and then it goes north again. But this happens only for a short time in winter. For all other time of the year, the situation is not so difficult. And when one goes through in the other direction from New York to London then the trip is easier because the wind is mostly coming from the back. Here you can see now the speed of such an airship. You can see the true airspeed, which might even go down here to 60 kilometers per hour. Maximum is maybe something like 140 kilometers per hour. And the speed over ground, that means the true airspeed plus the wind speed over ground, can go up to here 200 kilometers per hour. And that's for a trip from London to New York, and here from New York to London. Yeah, the London to New York and New York, London. Here you can see the battery charge level. We of course assume that the battery is charged when the airship is starting, and then it will be discharged during night, and it will be charged again during day. And this kind of charging and discharging has to be done in an optimal way in order to reduce the travel time. Yeah, here are now the results for different months in the year. You can see that the travel times also a little bit depend on the maximal altitude. In my opinion, a good maximal altitude would be, for example, 3 kilometers. And the difficult month is the January, February here. So some winter months might be very difficult, in particular when you go from London to New York, but in the other direction, it's easier. One mainly can say, particularly when looks to these two pictures here, that in one direction you have 3 days and 3 nights, and in the other direction you have 2 days and 2 nights. This is now another example, more for a mid-range flight from La Palma in Gran Canaria to Madrid in Spain. And you can see the travel time is nearly for all cases, roughly 11 hours, sometimes a little more or less. Only here in November, there is a difficulty because the wind situation might be very difficult, and additionally there's less sun. We also were briefly thinking about the parking and land use of airships. Some people are saying, hey, airships are so big, therefore the land use is very large, and they are not practical. But if one looks in more detail and assumes a certain parking construction at poles or parking with hangars, then if one is doing a more detailed analysis, then one can find out the land use of airships is not significantly higher, in some cases even lower. And what we also did not discuss here, really what kind of land use it is. As you can see here in the picture, often the land use is nevertheless grassland. So land use is similar to other means of transportation. That's certainly not a problem. But the interesting result is now the CO2 emissions. Of course, an airship leads to a zero emission flight, but what one has to take into account that the battery of the airship should be charged before it starts. And the CO2 emissions which appear when you charge this battery before starting the airship, these were the CO2 emissions we took into account here. And then you can see, in comparison to a heavier than air long-haul flight, the CO2 emissions are reduced by a factor of 25. So we have really very low CO2 emissions, even better than for a long distance train, as you can see here. So solar powered airships are really a very interesting technology if we would like to have a climate friendly transportation, not only aviation, but in general, a climate friendly transportation. Another thing which is very interesting is the fuel costs. We can expect that fuel costs in future will increase. They are already now high, but they certainly will increase. And then we can find out that the full costs by a factor, let me say, 50 to 200 less than the full costs of heavier than air airplanes. I think here one has to make a comment. I think the reason why airships are so efficient is because they have solar cells and they are directly using the energy harvested by the solar cells and converted to the thrust. And there are not a lot of different parts in between, and therefore this is a very efficient technology. At the end of my talk, I would like to make a comment how comfortable it is traveling in an airship. Here you can see two dining rooms. Here's the dining room of the R101 from England, and here's the dining room of the LZ 129 in Germany. And you can see traveling in airship is certainly even more comfortable than traveling in a train. And these results, which I showed you in this talk, are published in a paper which we recently published in this International Journal of Sustainable Energy. There you can read these results in more detail. It was a paper with Agnes Jocher and Tom Riffelmacher. And yeah, if you want to talk more about airships, you're welcome to take part at the conference on electric airship in September in Germany. Yeah, thank you very much for listening to my talk. Are there any questions?
Yes, thank you, Christoph. Yeah, are there any questions, folks? Again, you can put them in the chat. I guess that's the main way we're doing it, or I suppose even speak up. One question I had, Christoph, is in part of your analysis, have you gotten into the issue? I assume a lot of your examples are for passenger travel. Have you gotten into the issue of what would likely fares be, and would the fares be competitive? You know, I think of this New York to London run, and it always amazes me some of the low airfares that you see.
Let me see how I can go back. The airfare itself, we did not calculate. We calculated only the cost of the fuel, which you can say is can be neglected. Yeah. Of course, there are some things one has to consider when you, for example, would go 2 days or 3 days. It is like in a hotel, you know, you get something to eat, you have a room, a bed where you can sleep. So that's something you have to pay, certainly. And yeah, then there's this construction of this airship, but maintenance, I think, for such a solar-powered airship is also less expensive than for a traditional aircraft. It's similar to like electric cars. Electric cars also don't need so much money for maintenance. The question is just what is the price of such an airship? When will we have it, and how many? When we will have a lot of electric-powered airships, solar-powered airships, then the prices will be, I suppose they should be low. If you have only 1 or 2, it will be expensive. But when we have a lot, then it should be less expensive. But I can't give you more detailed.
Thank you. Yeah. Maybe that's one of the next steps. But yeah, that makes a lot of sense. Super. Does anyone else? Here's a question. And yeah, I believe this could be directed at you, Christoph. Due to the speed of charging and discharge, would supercapacitors be an option for the solar system?
You mean instead of batteries to take capacities, or?
You know, yeah, that question goes a bit beyond me. Maybe the person. Go on.
Super capacities. I don't know, actually don't know how much energy such a supercapacity can charge. If you can give me data. You're writing a yes in combination with batteries. Yes, maybe that's a good idea. I don't know. I never looked at super capacities. I only know the very small capacities for, but I don't know how the super capacities are. What is the weight of the lithium battery package? What is the power? power. Yeah, here lithium. Yeah. I assumed here a little bit a larger value. I assume 300 watt-hours per kilogram. I think we have the data here. You can also look to our paper. And I think the size of the batteries is roughly 10 times or 12 times that kind of a battery of an electric car. But that fits also to the number of passengers. When you have 100 or 200 passengers, then you certainly need a bigger battery than that one which you have an electric car. An electric car has about 30, not 10, I was wrong. 100 kilowatt hours has a car, multiplied with 30 gives this number. So for 30 electric cars, not 10, 30 electric cars. And that was, oh, here is written super caps, 7 to 12 watt. Okay, that's something one has to think about. If one, yeah.
Super. Thank you.
Yeah.
Thank you, Christoph. Yeah, perhaps we should move to the next talk, but if there are extra questions, please hold them, and then hopefully we'll have a bit of time at the end, or folks can certainly contact Christoph directly
Yes.
with those questions. But thank you, Christoph. Very interesting work that you're doing there. Okay, well now, you bet. Thank you. And next we have Kimberley Leach with us. She's the North American Market Development Manager for Ballard Power Systems, and also owner of Wind Farm Pros. She started in agriculture and then transitioned to the aggregate industry, and she has quite an eclectic education, including dentistry, construction, project management, economic development, renewable energy, etc. And she's also held key positions in government, including Deputy CEO and Director of Economic Development and Planning. And as mentioned, also she's the owner of Wind Farm Pros, a wind farm installation operation maintenance company. And interestingly, has amongst Canada's commitments on the greenhouse gas reduction is the hydrogen framework. And this is what led her to Ballard Power Systems, which is a Canadian company and global leader in hydrogen fuel cell technology. So with that, Kimberly, please take it away for us.
Thank you. I'm just going to go into presentation mode if everybody can, excellent. Okay, so who's Ballard? We deliver fuel cell power for a sustainable planet. Ballard, there's been a global momentum, and I think we've all talked about it throughout this presentation, which I have found very informative, especially with my background around economic development. But it's the whole global momentum to address the climate crisis. We have 55 countries now, if not since this presentation was done with Ballard, have carbon trade schemes. 93 countries have introduced net zero targets, and I constantly am fielding inquiries from the Caribbean and South America with the same questions and the interest in the different countries. And 163 countries out of the Fortune Global 500 that have a formal climate target, and Ballard does as well. There's no climate solution without hydrogen. Obviously, Ballard's whole core is hydrogen. So we have published hydrogen strategies globally, and many in draft or in preparation, or many of the smaller countries or less engaged economic countries have no strategy, and hopefully that they'll come together in that. And we're seeing a rollout across Canada with strategies that are coming on board, and the most recent has been New Brunswick. They released the call for proposals in October, and it's expected, if it wasn't out last week, it should be coming out anytime. And then obviously there was the discussion paper for the North, which is also very exciting. There's a strong support for hydrogen financially with the federal government budget announcement a month ago, I guess it is, 2 months ago, the Clean Hydrogen Investment Credit, obviously supporting between 15 to 40% of eligible projects for clean hydrogen investment, clean technology tax credit of 30% for zero emission vehicles and equipment, which aligns with the business practice of Ballard, obviously with heavy duty transportation and transit being our core business line, and the Clean Fuel Fund, obviously breaking down those barriers and making accessible hydrogen at the pump feasible, with a Canadian 1.5 billion and additional 3.9 billion for zero emission fund to help offset some of the costs for transit or fleet deployments. So hydrogen is key to the decarbonization of our economy. Hydrogen is an energy carrier. It's decarbonized multiple sectors and changed the future of industry today. It's supported by electrolyzing technology, and hydrogen is an important storage solution for renewable energy that cannot be distributed by the grid. And hydrogen is a flexible low carbon fuel for heavy duty mobility. And stationary hydrogen fuel cells, which Ballard has a space in, and I'll talk about that shortly, is an energy on demand for various sectors. Example, backup power, grid balancing, or power to power. So this is definitely a growing emerging market for Ballard. So in the space of the whole hydrogen world and what it looks like, Ballard is the yellow circle. We're focused on the market focus of transportation, clean mobility, and clean transportation with some stationary power, and that includes marine application. So here it is, the most competitive, we're competitive in the heavy duty motive application sector. Buses and coach are our #1 core investment line, with trucks up and coming, trains are coming on strong, and we also are interested in the marine sector. We do have a Center of Marine Excellence in Hobro, Denmark, and we actually have some vessels that are deployed, and aerospace is not currently a very active space for Ballard, but that's part of my core development and the rest of the team that's in market development looking at the aviation space. So the advantages of fuel cell electric vehicles and what do they actually bring to the market in decarbonization? They can directly replace diesel 1-for-1, route on all conditions. They actually all weather performance all day long. So they stay consistent throughout their performance, long range with a maximum payload, less battery, more payload, and fast refueling times compared to battery charging. So just a quick overview. This is a slide. I actually threw it in this morning. It wasn't in the general presentation, just so people can see, and this is based on a bus deployment, what different type of fueling infrastructure looks like at the pump. So you can bring in, for a deployment project, bring in compressed gas trailers that are run through a compressor, and then it's put into storage tanks, and that's good for buses that run on, a bus runs on about 30 kilograms of hydrogen a day, so that would fuel about 10 buses. Great for deployment projects, like I said. Liquid hydrogen delivery, obviously more density. Liquid delivery for 10 to 100 buses, you'd actually bring in more and store more on site through liquid tanks. And then on-site generation, where you're going directly through an SMR process from natural gas through the compressor into the tanks and then into the bus. So that's more convenient in larger centers or along pipeline routes. And then the electrolyzer option, which is feasible off of renewable energy projects through electrolysis, then through the compressor, and scalable for process of larger volumes. So battery fuel electric vehicles work together and are the right path to net zero. So there has to be an equal balance to equalize decarbonization, and it's going to allow for the fastest route. So passenger cars, you're going to have more of a share in battery, obviously, medium heavy duty trucks, but heavy duty long haul trucks, there will be an equalization, if not more, production eventually with hydrogen because of the long payloads and the lighter payload capacity that you'll have. For important segments of road transport, hydrogen is the best option. Regions are with constrained renewable or grid capacity in mid to long term. Vehicle segments with high power and energy demands are critical. So it's greener, it's faster, and it's cheaper. So you're going to see a scale up towards hydrogen and long haul transportation, which is going to be important in the future for accessing the north. The hydrogen is also competitive for power generation. I know through the infrastructure study that's released in looking at those northern communities, sustainable power through hydrogen power generation is still in development because of the nature of water within the fuel cell units. It's still got to be addressed in colder climates, but in the future, it could feasibly be a solution for backup generation power in northern communities. So who is Ballard? So fuel cell innovators over the last 40 years, we have a long hold. We're dedicated to accelerating the adoption of fuel cell technology. Fuel cell expertise, we deliver fuel cell product performance for a low life cycle cost. We have an excellent customer care mandate. We're specialists in the industry, and we're there throughout the stage of deployment and the life cycle of that fuel cell. And we offer integrated energy systems to remove the adoption to barriers. So we're really proud of where we are today and where we're going. We have over 1,100 employees. We've scaled up significantly, and we're consistently recruiting to meet the demands and specialized expertise to meet the demands of the technology and where it's going in the future. We have over 1,400 patents. We have a 2030 commitment to carbon neutrality. There's over 1,400 transit buses running on our fuel cell technology, 2,300 trucks, 7 trains, 8 ships. Like I mentioned, Hobo, Denmark is the stronghold for that, and 8 megawatts of stationary power projects. And that's obviously growing daily with orders of over 100 buses in the United States coming forward due to the low and no funding. So we're really proud of that, with over 150 million kilometers in operation and 4 production sites. We just opened up another production site in Bend, Oregon, so we can compete in that Made in America plan. So again, Vancouver, Burnaby, BC is the headquarters. That's where we've always been. We have over 100 fuel cell electric buses in service now in the United States, multiple truck demonstration projects. Some of you might be familiar with the Transition Accelerator Program in Alberta. And then we also have 2 fuel cell buses in operation now in Edmonton and Strathcona County. That's the first cold weather deployments that we can relate to since the early deployments during the Olympics. And we are partnered now on a data center backup, which is critical because batteries have a lifeline of 72 hours. We can be sustainable with that hydrogen infrastructure. So Microsoft has moved into a relationship, and we also have a CP rail freight locomotive project taking place as well with additional orders. Our markets: bus, truck, train. We're now into the mining sector, which I know has been a topic today with Anglo America looking at open pit mining, and where we're going with that is continued growth and interest in stationary power. So over 43 years of pen cell production and expertise, the performance, the durability, and it's rugged. The promise is end-to-end support and engineering and integration. That model that you see there is the rooftop model that's actually used on the transit buses. They have 2 options, rear mount or top mount. So we've seen significant growth in the technology from 2011, 20 kilowatts, life cycle of 1,500 hours, zero freeze start. We're now down to -30 with complete balance of plants with 2020 in the future, scaling up stack power with 150. So there'll actually be a module that looks like an engine module going in the front of transit trucks, transportation trucks, with a power density and a longer life cycle of 50,000 hours and a -30. So definitely looking at cold weather deployment. We're a virtually integrated manufacturer. So right from the fuel cell stack to the PEM development to the fuel cell stack to the balance of plant, and working with integrators throughout the life cycle of the project. So here is the 3 main lines of the fuel cell stacks. You can see here that the fuel cell gen HPS up to 140 kilowatt stack is scoping up to be in the aerospace industry. We have a comprehensive range of technology, right from fuel cell FC Wave, the 45 kilowatt, to the rail, which is really an emerging strong market for us. And the FC Wave unit, the 200 kilowatt that you're seeing in the middle of the screen, That's used in the marine sector, but also in stationary. So there's dual purpose for that. It does have, obviously, its exposure is a little bit more for cold weather. Exposure to the piping with water is a concern, but it's something that's being addressed. And then the ClearGen 1.5 megawatt unit that's currently in deployment in various aspects in warmer climate. So we offer battery fuel cell integration, the energy system powertrain integration. We work with partners and technology solution programs right through to the financing end of the integration, the asset financing and project financing. So we have world-class test capacity and infrastructure with over 400,000 hours of test data on our fuel cells and 100 fuel cell test stations and specialized tools, including 11 environmental climate chambers. If you haven't been to the test facility in Burnaby, if you're interested, please let me know and I'd be more than happy to try and arrange a tour for you. We expanded our MEA production capacity 6 times in 2021 and continuing to upscale to meet the demand of the global interest in fuel cell technology. And globally, we're in Vancouver and Bend, Oregon. And obviously, we have some ownership out of Wangfang, China and Gudan, China, and Europe being our stronghold, with most deployments taking place in Europe right now. So again, we have 1,400 buses, 2,200 trucks, 7 trains, and 8 ships. I'm just going to show you the New Flyer is our partner in the transit industry in North America. Strong relationship, great integration in technology, strong performance, averaging around 350 miles or 550 miles or sorry on the conversion. And so great performance. That's our offering in North America. This shows you the energy flow and management on the architecture of a fuel cell bus, just to give you an idea of what that, for those people that are not familiar with the technology and how it works. So right from the hydrogen production to the on-board fuel storage tanks and the high density tanks, to the traction motors, to the fuel cell system. And what's nice about this, and you might hear with battery in the north, we're running into discussions where people have bought battery technology, but in order to heat the cabin or keep the increased range, they have to put diesel generators back in. And some of them are actually burning up to 80 liters a day per unit to keep that bus cabin warm, where you can actually capture the heat from the fuel cell and put it into the cabin and eliminate that addition, because technically they're not meeting the zero carbon credits that they would be required to do. So there's a challenge to keep the range in battery, and then obviously the auxiliary inverters into the bus. And then we have Solaris, which is our competitive bus in the European market with over 350 kilometers. We have Quantron Truck is a partnership that we have. We are working with other integrators for truck solutions for drayage trucks and Class 8 trucks, which you're seeing deployed into Edmonton right now for the Transition Accelerator project. The Anglo-American mining truck, it's a 300-pound truck for Anglo. It's in South America. They've placed other orders, each with a megawatt scale fuel cell power. The CP locomotive project, very successful with the FC wave units. So there's 1.2 megawatts FC waves on each one of those module trains. And then we've partnered with Siemens for the Miro Plus H2 project in Berlin region, and it's a rooftop module that they put in there. And then the Norled Ferry, you're going to see more of this taking place. It's successful. We're starting to see different studies starting to come out. It's early stage in Canada, but there is definitely interest. But this is out of the Hobro Center in Denmark. And then again, the renewable stack, Renew Stable, the ClearGen system in French Guiana is delivered 365 days of 24-hour zero emission electricity to the grid. We support our customers throughout the journey with ongoing technical, on-the-ground technical assistance. We're here for life. So our carbon neutrality commitment's 2030. So at the end of a life cycle of a stack, we actually pull it out, take it back and rebuild it and send it back out into production. So we try to capture as much as we can to reduce our carbon footprint of our products. And we want to be a leader in the industry and educate the next generation. So that's who Ballard is, and that's who I am, as I'm their market development manager for North America. Thanks, Paul.
Thank you, Kimberly. Very interesting. We do have a few questions that we might address, but we will need to move on fairly quickly. Maybe a couple of the quick ones here. Someone asked, how involved is China in Ballard's business?
They are a strategic investment partner in Ballard and a very strong interest for Ballard. Obviously, Ballard was a Canadian company, but with global growth, there is strong interest in technology development within the Chinese market.
Thank you. And where does Ballard do their cold weather testing?
Well, right now we're proud right now to be part of the Alberta Transition Accelerator. And keep in mind my background in economic development. You know, I'm obviously looking at regional partnerships, and I've opened up. I went back to the test bed facility in Churchill, Manitoba. Sorry, not in Churchill, in Thompson, Manitoba. I think there's a strategic alignment there that starting to look at that opportunity in the northern part of Manitoba again and opening up that area because it's world renowned, their facility. We don't currently test there, but right now for us, it's in Alberta.
Interesting. And maybe one final quick question. Someone's asking what your thoughts are on white hydrogen.
I don't comment on the color of hydrogen. I like green.
Okay,
We like green. At Ballard, it's green.
Fair enough. Thank you, Kimberly. And again, like before, if folks have more questions, you can get in touch with Kimberly directly or add them to the chat. We might have a few minutes at the end of the session. But
thanks, everybody.
Yes, thank you very much, Kimberly. Now, I think without further ado, we must move on.
This would be a good opportunity then to open up the floor to all the speakers, because many didn't have a chance to have many questions. So why don't we do that right now, Paul? And certainly, I think some of our first speakers didn't get much chance to speak. And if there are questions from the chat or from the audience that you'd like to direct to any of the speakers, hopefully they're still online, and let's go forward.
Super. Yeah, I see Christoph is here, and I believe Kimberly still. Yeah. So are there other questions that folks have? Let me see here. There seemed to be. There was one interesting one. Yeah, here's one. Maybe I think it could be directed at anyone. Maybe I think it was when Kimberly was speaking, but about the Tesla's push in California. But then with this complaint of financial unsustainability due to the cost of hydrogen. If the cost doesn't come down, will all your technology be for naught? Any thoughts on that, on the cost issues? And I suppose it could be Christoph or anyone really.
He understands the question. Otherwise, he could say something. Is it something about comparison of using hydrogen and batteries, or?
Yeah, yeah. And I don't know if our Annette is out there, but yeah, it was about what Tesla's doing in I believe in California, or maybe the CA. I guess that could either be California or Canada. But perhaps we should move. There was a very interesting one from Jesse Glenn here. And let me, it's a bit lengthy. Let me read this one. Exactly 95 years ago and 1 week today, the semi-rigid airship Italia took off for the second crossing of the North Pole, etc. But the question is, how much will wind, snow, and icing affect modern airship operations? And are proposed airships being designed with an active icing control system? I guess that could be for several of the speakers.
Paul, I can sort of refer to some of that. It's correct that we do have to do cold weather testing. And the the airship did make it across the pole. It only went one way, but it did make it. And the answer is we don't really know because we haven't done the work. What we do know is that there are materials that will shed water more easily. One of the ideas put forward is to have solar panels along the top of the airship that can then be heated by the sun, or I'm not sure you can reverse them and heat them, but to remove any snow or ice. The only issue for an airship is weight. It doesn't affect the aerodynamics, but if you are accumulating ice or snow, then that's going to be a problem to fly. In fact, from the history, we know that the old Zeppelins, when they get into a rain, they would add 5 tons to their weight just with the water on the envelope. So they also worked very hard to try and find materials that would shed the water easily. So I think there are solutions, but nobody can say definitively that we have them in hand.
Thank you, Barry. Here's an interesting question that could go to any of the panelists from one of our colleagues, Nathan Ghattas here at the school. General question to any of the panelists: the economic, environmental, and social case for airships and hydrogen seem to be compelling. So what are the key resistance points slowing down their adoption and diffusion? Yeah, and again, any panelist that has a thought on that, any speaker.
Well, in truth, Paul, that may be something we could have to address to the next day's panel. And it's a good way to tell everybody, come back tomorrow, because we will have airship companies that'll be speaking, and they can speak directly to that. I think the fundamental issue, however, has been just the lack of capital. The airship industry, everybody knows, has had a lot of baggage. Some people look at it and say, well, it was tried and didn't work, why try again? But of course, we could say the same thing about electric cars and about wind turbines. Both those technologies were used and abandoned, and now they're back with a vengeance. I think the same thing will apply to airships, but it does come back to business confidence. And clearly, one of the things that we hope to do with sessions like this is to demonstrate where is the demand and where are the markets. Clearly, if someone had an airship that could move those critical minerals, there'd be a lot of parties that would be interested in using them. We have a problem in the north trying to serve our remote communities, and we don't have a solution. And we've been now more than 20 years talking about this. The situation hasn't gotten better, and nobody's come up with another alternative. So in the light of that, the question rises, well, why aren't we at least making efforts to find out whether airships will work? And I think that's all that we have been able to say all along is, why aren't we making more effort towards this? So it doesn't really answer Nathan's question. And I think I would ask him to pose that tomorrow to the airship companies directly.
Oh, yeah, that's a good one. A brief thought I had, a question I've had for a while now, and then we do have a couple of additional questions come in. With some of the high-profile billionaires, Elon Musk and I think Bezos as well, interested in aerospace, I'm a little bit surprised that there's no traction, with some of this big money into airships, some technology right here on Earth instead of going to other planets. Any thought on that? Is there any traction, from the heavyweights, I guess, in the investment industry that also seems to have an interest in things aerospace?
Well, there is indeed. In fact, there's a project in the US called LTA Research, and it is funded by one of those parties who is sort of the anti-Elon Musk. He doesn't even want us to mention his name, let alone anybody know about him. So, but this project is well underway, and in fact, well advanced. You can find out more about it on the internet, called LTA Research. We had invited them to speak tomorrow. Unfortunately, they can't make it, but certainly that is one of the cases where there is the financial backing and wherewithal for this to go forward. The other example actually is Flying Whales, who is going to be speaking on the program tomorrow. And in their case, they received a very significant amount of investment from the government of France. And the government of France wants an airship that can remove logs from its mountainous areas, because they do have a shortage of lumber and they'd like to exploit that area, but they don't want to build roads. So they are investing in airships to do that. This has also been added to by the government of Quebec and Canada. They've invested some $50 million in flying whales, and they have a subsidiary office set up in Montreal. And their intent is to build those airships in Montreal once the project gets going. So the answer is yes. And finally, I would say HAV, which is hybrid air vehicles out of London or England, is also well advanced in this development, and there are more that are coming.
Interesting. Yeah, I noticed an interesting question here came up. Will the airships be made to handle both passenger and cargo simultaneously? Which, you know, of course, is quite a thing in the air cargo and airline industry. Any thoughts on that? You know, on the simultaneous movement of people and freight?
It's almost certain that this will be the case in the north, because this is what we do today with airplanes. Is we do have combi airplanes, which are maybe more than half of the capacity is for freight and the rest is for passengers. And I can see that happening as well, certainly for the north. The airship companies logically would want to start, if they could, with cargo, because the regulations are less daunting in order to get certification to move goods than it is to move people. That being said, one of the companies who will speak tomorrow, HAV, is dedicated towards passenger transport alone. So they are actually going forward with an airship to be certified for passenger transport. It could also move goods, of course, as well, but I think it's designed mainly towards the passenger market. So different airships for different types of uses, and of course, designs thereof.
Thanks, Barry. Now, yeah, another question I had, you know, I hate to monopolize questioning here, but I guess this would be directed specifically at Gage, perhaps others as well. You know, but I found your talk very interesting, Gage, about your closeness to the remote communities. One thing I often wonder is what are the communities actually saying? Because the last few times I've been to Churchill and other places in the north, there seems to be a bit of a movement to, you know, for instance, growing, you know, certain vegetables, growing things hydroponically in freight containers. Yeah, and so in other words, you know, trying to meet needs with stuff that's there, and in a sense, reduce the need for you know, inbound transportation. So I just wonder, is that part of, you know, in the bigger picture, sort of the overall situation? You know, using, and yeah, it was mentioned, I think, you know, the hunting, the fishing doesn't cover the whole need, but any thoughts on that? I guess what the communities are actually saying. All right, well, maybe my question was incoherent, and that's fine. Okay, we have another one here that came in regarding the combi airships. Oh, and maybe this looks like more of a statement, isn't it? Yeah, with a passenger capacity of 19. Okay, super. Any other questions folks have? And here's an interesting one asked by Coco Beans. Could airships be readily available for emergency rescues or fighting forest fires? Which, of course, if you've been following the news, this is a huge thing these days all over Canada. Any thoughts on that? Could airships be used for emergency and fighting the forest fires?
Well, Paul, they could certainly be used for emergencies, and they could bring things to a forest fire. The one thing everybody has to recognize is that airships stay aloft because they displace the weight of the air around them. So if you're heating the air, it has less lift. So you'd never fly an airship over a forest fire because you'd like to fall into it. So you can't use an airship to deliver water to the airship, to the forest fire, to put it out. But you can certainly bring things up to the people who are looking after the fire. And there's been talk about, you know, the difficulty when you're in a remote area, especially with a fire, with how do you keep communications? So the airship could be as a communications hub to coordinate all the parties on the ground. So that's one of the places where we've seen discussion of use of airships for forest fires. Of course, for other disasters, this is some of the main aims of some of the airship companies, is to be able to deliver goods where you have a destruction of the infrastructure. And certainly, I believe we'll hear more about that tomorrow.
Oh, super. Yeah, I recall back in the day during the I don't even want to say the first one of the Darfur region crisis in Sudan, where there was talk of, from the port, it was like a 2,500 kilometer journey, but rather than using the roads and all the perils, the bandits, etc., moving goods into the remote refugee camps by airship. Here's a question for Ross specifically. How do you envision over-dimensional cargo, such as building products, would be lifted? What limits maximum volume dimensions?
So, I mean, I think from a maximum dimensions standpoint, we're probably looking at whatever the aircraft would be able to do in terms of net length. I mean, you'd be a little bit limited, again, depending on the nature of the size of it. In terms of actually loading the cargo on, we've got a couple of different methods that we can envision using. One of them that I see as a major possibility for us would be to have the aircraft tethered in a fashion where you've got the securement points all held down, and you allow the aircraft to rise to the height that you're looking to load at. And then you can position the load underneath, sling as you need to, attach and adjust ballast, and then release your cables and remove the load and the aircraft from the table at that time. Ultimately, so these things, a lot of it's going to take some specialized cradling and some specialized pieces and things like that to be able to ensure that you can hold the load the way that you need to be able to maintain balance. You can't just put a big heavy object in the back of the craft and expect you're going to pick it up and it's going to work. It's got to be balanced in the middle. So there'll be some things that you'll have to work out in terms of those operations. But as far as maximum size, I mean, again, it's really dependent on the aircraft and the overall lifting capacity of it. I think from a size perspective, there isn't much that this wouldn't be able to handle.
Thanks, Ross. Interesting. I think it's about time for the closing, but I just wanted to note, Daniel Hebert made an interesting suggestion that airships could be an eye in the sky as a watchout for forest fire sensitive areas. And I would imagine, even could you have an airship up there with a lot of water, in the sling or what have you, and then if it sees just the initial start of a forest fire, drop a load of water on it, and maybe put the thing out before it even gets big, and that then you won't have that problem that Barry mentioned of being sucked down by the massive fire.
Many ideas, Paul, and indeed, how you adjust for buoyancy after that is one of those questions. But nonetheless, this really speaks to many needs that are not solved. There's many things that we need to do, and the airships aren't going to be perfect for everything, but they certainly have a lot of different applications, and we've explored some today. Just in winding up, as we are running out of time, I'd like to thank everyone for attending. We are recording the sessions, and the intent is to have this available for public viewing for those who missed the sessions, or for those who want to go back and see some part. Your link that you used today is supposed to work for tomorrow. And again, I apologize for the delayed start. We had some issues with another webinar that was just ahead of us. But we should be starting a little bit earlier than 9 o'clock, so you can check in. That's the hope. And your link should work. Those who have also registered for day 2, obviously use that link and you'll get in directly and guaranteed. We do have a good program for tomorrow. We're going to be talking about some of the airship companies will be presenting, but also we're going to be looking at some of the regulations. Hydrogen has been talked about today. We're going to talk about that more tomorrow. Certainly, it is the key to zero carbon emissions for long haul movements, notwithstanding the role of solar. And indeed, these things can be used together. You can have both at the same time, and that I'm sure is something that Dr. Pflaum has probably been thinking about too, in terms of rather than having as much backup with batteries, perhaps fuel cell and hydrogen might be another alternative to provide. And there were comments I noticed in the chat about the the safety of batteries. And clearly this is something that has to be worked out because regulations for aviation are very strict. And so what we do has to fit within what the regulatory authorities will allow us to do. And that's certainly part of our future. So thank you very much, everyone, for your attendance today. We got started a little late. Maybe we can finish on time, which I hope is the case. And I would like to thank all the panelists for your presentations. They were excellent. I certainly felt that I have learned more today, again, on various topics. I think the critical minerals strategy is a really interesting development for Canada. We certainly have an opportunity to expand our supply, and these minerals, as I'm sure recognized by everyone, without these minerals, we cannot make the transition. We have to have these inputs in order to develop more electric motors and batteries and other products that we need in order to shift away from carbon intensive developments. And so the critical minerals are a part of that. And I think the airships have an important role to play for us to be able to extract them in a fashion that's economic, but also sensitive to the environment and to the people who live in that area. And there's certainly reasons for us to consider the airships as being a more rapid way of developing these critical minerals than, say, the traditional approach of trying to build roads. I would just point out that one mine in particular in Canada that's very well known, the area is called the Ring of Fire in Northern Ontario. It's now been over 15 years or longer since that mine was announced and wanted to go forward, and they still haven't done an opening because they still don't have road access, and there's still debate over who should pay for that. So in that sort of intransigence, I think the airship has a role to play, and I think it will be part of our future. So with that, thank you very much, everyone, and I look forward to seeing you tomorrow at 9 o'clock Central, and of course your local time. And thank you so much to our hosts, the chairs, and also to all our speakers, and we'll say goodbye for now.